The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philipong, here with Mr. Dane DuPont for HawaiiTracker.com, bringing you guys another Kīlauea eruption update, today May 11th, 2021. It's been another interesting week at the summit of Kilauea. The eruption continues here. What we have now is a retreating of the lava lake surface. The crusting is still happening. It hasn't happened as fast this week as the previous two, but it's still happening. And it's led to some more morphological changes, the changes of the shapes of things here that we're interested in sharing with you guys today. So starting off here at the top, this is the area below the west vent, and we have essentially a perched lava pond up here that's spilling over into this lower part of the lake, and that's what the story will detail for you guys here today. But before I get to that, I just want to make sure that we mentioned that we're going to be He's going to be manning our streams and checking air quality, so if any issues, please report to him, and collecting your questions, answering what he can in the chat, and we'll do some discussion of viewer questions here at the end as well. Just a second here. Having an issue with my drawer is not showing up. But
always something.
Yeah, doesn't want to show up today for some reason. Well, I may have to. I'm not sure anyone can see my pointer there, but I may have to illustrate without it here. So I want to show you guys I'll show you guys this first image right here, which is a USGS-HVO image. And that's kind of a zoomed in version, and here's a version that's a little bit farther out, and it shows similar that upper flat area. You can see where it's red and orange, and also where it's silvery gray. I'll zoom it in here for you guys. That's that more liquid area, right? That has a crust that's a little bit thinner, and you can see a couple gaps here, one on this southern side and one on this eastern side here, that are spilling over into what was the original extent of that lava pond down there. Okay? And this area down here seems to be forming a crust more quickly. You can see lots of these pahoehoe ropes all through here, but it also is undergoing the crustal overturning and foundering, where you see the whole surface get replaced, and you can tell it's still liquid underneath this whole area over here. Right? It's a little bit hard to tell, but at the bottom of the frame here is the edge of that big island that was the one bobbing in the middle of the large lava lake for such a long time, and now is the eastern margin of that smaller active area. So the lava now is coming in through this west vent up here in the top left, coming in through this submerged inlet, ponding in an area up here. But what's happened is there's been a lot of crust forming, and a lot of this crust has started piling up against the edges here, and especially wherever you have any of these islets, any of these old little islands or little pieces of crust, or any nucleus of cooling already, where you start to have the rock be a little more sluggish or a little harder, and that starts piling up, and that's forming a levee. It's really interesting. We have a levee here within the pond, so we have an upper inner pond, and it's spilling over, cascading down, if you will, into this lower, also perched pond. It's perched below the areas to the side. Let's see if I can. Oh, I can't in this photograph here, but down over here on the right side, you can see this actually sagged quite a bit down. You can see the gap up here, this shadowy part here in the top right of the old levee where the lava was, and as it's withdrawn and retreated, now we really have this elevated area closer to the west vent, and that larger area of that open surface that we had 3 weeks ago is now really down to, I would estimate, about a third of what it was 3 weeks ago or so. So really interesting development there. What I want to do is play for you guys some time-lapse compilations that I've put together here, kind of showing this process. And so we'll start off with the same view here from the south. These images from USGS from the south rim. So now we're going to go to the S1 camera, and it is a little blurry, but this area right in here is where that inner perched pond is going to form, and you can see the flow going down to the edge of the big island down here at the bottom right of this image. So that's our pathway right there. I have us looped a few times just for the last a few days here since the start of May. So you can see how this area develops, and these open spillover channels, they haven't closed at all, right? So it's interesting that you see more ponding up here, but it's almost like lava tubes forming and continued overturning and action and movement in these lower areas down there. So if I zoom it out to see how have a better view of what's happening, that inner pond is right in there. And we have this lower area in the southwest and the northeast that we reported on 3 weeks ago. And now we're looking at this smaller area right in here, right in the middle. So there it comes there in that wider view. That's the daytime images only. If we turn to just looking at the nighttime images, you don't see as much of the detail, but it is cool to see the overall pattern. So that is coming up here next. There it is. Zipping up, so to speak. Showed a couple more times. All right, just over the last month or so, how that lava surface has retreated to about a third of what it was before. So now we'll turn to the thermal camera. This is an F1 camera. And once again, I've got, since the beginning of May, just looped here, so you can see how we come in from the northeast. We're now looking from the reverse, so now north is to the left, but we're really zoomed in here, and oh, that went too quick for me here. I'm going to pull it back, if it will allow me here. All right. I'm going to come back here to the thermal view right here. All right, so north is to the left, and the west vent is here at the bottom, this little glowing orange dot, and that big island is up here below this date timestamp. And so the flow is coming from essentially the bottom left, bottom middle to the upper right middle, right through there. And that smaller area, the perch pond, is right in here. And we actually have overflows from that area. So you can see a big fan over here to the left. That's a spillover into that lower area. And there are also spillovers happening in other sectors of this pond as well. But seemingly the area over here to the right of that pond, right, that area seems to stay pretty open, and it seems to be a pretty steady flow through there. So right now there are dual pathways, one coming down this channel and turning up, and the other going essentially more straight across. And those have not at any point closed off that I can tell. They do seem to kind of zip up and form tubes on the up pathway portion, but then that essentially are founders and the crust breaks back open. And you see it continuing flow more obviously when the crust is absent. But it's presumably flowing in that direction underneath that crust that entire time, still maintaining that flow from under this west vent to under this big island over here in the east, from west to east. And so I'll play it now. You guys can see it. Can see it zip up. And then I'm going to zoom in a couple times, and we'll show you guys some of the detail of the boundary right in here. Right, so you can notice that there are some of these darker purple pieces and pink pieces in here. These are the cooling crusts, and the darker one over here, this is a little islet, a little piece of perhaps the west vent or something more buoyant that was floating like a small island, right? And we're using the term islet because these are much smaller than the previous islands we had, but still a little island really. So they're in there as well, and they're acting as little nucleation centers for all this cooling material to expand from, right? So as we zoom in here, you can notice these these purple areas, darker areas, are actually moving as well. And you can see how that either slabs of crust or masses of cooler lava that are moving near the surface are getting rearranged within a small area in here. So let me play it here. You guys can maybe see this wide angle view. First overflows and less overflows going farther away. Even though we're still having overflows, they're not going nearly as far as they were a week ago. So that is retreating as well. So zooming in, you can see right in here that seems to be a flow of that hard material right towards the east, right through there. And you see this one over here also wiggle a little bit as well. We're going to zoom in a little more just to make it quite obvious that there is some interesting stuff happening there. You can't quite tell from the thermal camera exactly what that stuff is made of or how solid it is all the way through, but it does appear to be some more cooled material, right? So we can look at it a little bit more slowly now. Going back a week ago, May 4th, you can see more of this flow and overflows, occasional overflows. The foundering, you can kind of see it flashes from that pinkish purple to more of the oranges as all the crust is replaced once in a while. So you see kind of a pulsing effect there. And that's a natural thing that can happen just from the crusting over process. But we are seeing some small deflation-inflation events also in the tilt meter coming in. So there could be other pulses coming as well, although they are also not big. And overall, that's allowed essentially a fairly, even though the amount of lava coming into the system seems to be less and less and less and less every day, it hasn't been varying wildly up and down. It's been doing a more slow decline, and so that's allowed this inner level to develop and raise and perch, and really see it pretty well right in here, this overflow pulse with the inflation event that just came in today. I'm going to pull that one back. You guys can see that last little section here again. Too far. All right, just the last couple of days here. And really see how we have a nucleus in here, and we actually have a big piece of this darker material right in the middle as well that's been migrating to the east as well. So interesting to see how these will disrupt, or if we have lots of smaller ponds, essentially this is that epimagma material perhaps that we are seeing back from 100 years ago. So zooming out here and looking at the whole last month, you can see that retreat once again as well. From that, really 1 month ago, we had that 8-acre area of lava lake, and it was down to 3 acres, I want to say 4 days ago or so. So we're probably perhaps in the range of 2 to 3 acres, somewhere in there, which puts us in the range of about a third of where we were a month ago or so. Unofficially, there's not been any official number put out by the USGS. All right, so we're going to turn now to show you guys the plot of the lake depth, and the lake depth is actually jumped up in the last couple of days. You can see right here, in the last 24 hours, really, you can see right here at this right end of the graph, right in there, that it's come up essentially about a meter or so. I showed you the scale on the left. You could tell that we're up around 229 from 228 as it was 24 hours ago, right? And that's likely due to that damming effect and that inner pond being perched higher, because that measurement's being taken, I believe, in that westernmost area near the entry point in that inner pond area. So it could be that that's the difference in elevation that we're seeing is might be in the order of about a meter or so between that upper pond and that lower pond, perhaps. Could be a little bit more than that as well, since that effect was happening before yesterday already. Right, but it's been most drastically obvious, apparent here in the last 24 hours or so. It's interesting stuff there. You can see that it actually has been climbing despite that. So really, we're up to a record of 229 meters, 751 feet deep is our current value, and that's just in that smaller area, even though we do have not far behind that a larger area and a lot more crusted stuff that has lava underneath throughout the rest of the system here. This is just the past week. So finally now we had our noise scroll off the end of the graph. I can show you guys the past month. So here's the past month. And that jump we're showing you guys is right here at the right end of the graph. So that's just the most recent thing. You can still see the upward trend over the past month with variations, plateaus. It seems like it comes up in pulses, right? It comes up and then maybe here's coming down and it's more or less stable. It comes up, stable, a little fluctuation there. Come up, stable, come up again. Right? So perhaps this might be the level of that lower pond right there. This is the process of the inner perching happening right in here, perhaps. Not huge amounts, but very interesting. And it could be that this crusting process continues and we end up not having such an interesting, beautiful snapshot of cascading one pond into another pond inside of a giant pit in a volcano for very long. So we'll appreciate it while it's there. All right, so that's the 1 month plot. And the reason I've been saying there's less lava coming out is because of these SO2 measurements that we have coming out, being reported by the USGS here. The most recent one reported from yesterday is down at 150 tons per day. 150 is well within the background amounts, right? You don't have to have an eruption happening to have that amount of gas coming out. So essentially, there's almost no eruptive gas coming out. It's just a background essentially at this point. You could argue that's what it's been the last two measurements here, where it's been 200 and 150. Before that, we're in a 350 is up to 600. You could say, well, that's, we've had values that are like that leading up to eruptions or more associated with eruptions and surrounding eruptions, but having it decrease in the last 2 weeks from that 600 value, which was already lower than an 800 average for the previous 2 months. Now we're down to 200 and 150 in the last week. That's really, for this volcano, pretty much nothing. And so you got to wonder, how long can this lava keep coming out if the gas is essentially telling us the magma supply is flat? Not to say it's spent and it's gone. There's probably still a lot down there, but it's flat, that it can't erupt its gas anymore, and it's the gas that's bringing the lava out for a lot of the part. All right, so really interesting to see reduced gas amounts, reduced lava amounts, but lava lake still rising in a smaller area, closing in, because that lower gas is also allowing the crust to form more quickly, and the crust is then piling up and making that perched edge, and the whole area retreating all as a whole in concert all together there. So we can look at the deformation data here, and the past 2 days we can see coming out of a deflation-inflation cycle. This is +1 and -1 top to bottom, so 2 microradians is a small one. If we go to the past week, we can see that we had one that was 2.5, and before that another 2. And looking at the past month really might give us a better context, because we had deflation-inflation events that were in a range of 5 or 6 microradians large previous to the turn of April. And really, since this low gas levels, we've had deflation-inflation events, but a lot smaller ones. They've been very frequent, but a lot smaller in magnitude as well. So that's that relative stability right in there. It is variable, and that might be part of that pulsing effect that we're seeing. But we haven't broken it down minute by minute to really link any one of these to any one of those pulses. But be surprised if at least one is not linked to some of those bursts that we saw in the time lapses there. So right, that's the tilt there. And one more thing before we turn to the GPS, there is a new map here, contour map from the USGS, and so this is not showing any new volume. It is showing a smaller area, active area of 1 hectare, 3 acres. So that is 65% of the 8 that they had the previous map 3 weeks before. Reporting 229, 751 here as our depth. And really the big difference is this red area is showing that extent of the active surface area now, right? So it's actually now quite, you can see visually much smaller than the size of the former water lake, which was more or less our measuring stick for a long time, our point of comparison. That our previous open surface was about that size as well. Now it's really shrunk down, and you can see that it's really a small area, and will not be surprised if it closes in over the next week or so, and possibly gets all the way crusted over here by the end of the month. At the latest, you would be surprised. Or it's not to say something couldn't change there, because I do want to turn to the GPS here, but I do want to also show you guys one last way to show these plots here. I want to show you guys the SO2 at the top, and the tilt in the middle for the 1 month, and the lake depth here in the bottom, all one next to the other, so you can really see decreasing gas values, essentially steady background up, but very variable deflation inflation tilt record, and a rising lake level, right? What's not being shown here is the lake area, which is reducing over time, and that's following the SO2 here. So that's the kind of a summary of all the signals we're seeing here together. And there's our map. And so let me come down here to the GPS. And the GPS is still interesting because we are still having some wiggles here, some little up and down variability. The long-term trend is still there, and clearly that most recent deflation inflation pattern may have affected the span of this data here, but we're now past that, and we're now resuming, and possibly even at a slightly increased rate than we were the previous month, where it was a little flatter right in here, and more similar to what we had prior to that in this range, where we had essentially from mid-January to mid-March or so, right, when we had a stable, continual effusion without as much shrinking of the lava surface, the open lava surface. All right. So this long-term extension is really interesting because this is the one signal that's different than the rest. So this is really pointing to some complexity, right? There's going to be some complexity down there where the volcano is still, caldera is still spreading, being shown by this GPS. The points on the side are still very slowly. Maybe they're rising, they're definitely not falling. They could be holding steady instead of rising as much now, but they're marginally rising still. So long term, you imagine there's still magma coming into this volcano, pressurizing it from below, and maybe that's what's pushing this upper bladder that maybe is not as well connected to the bottom, and maybe that's what's leaking out, and that's the portion that's spent. And there's some deeper underlying other process that might be causing the signal a broader influx into the volcano or adjustments in the ground. I really don't know. I'm just putting out some ideas there, but that's the juxtaposition that we have to consider here, right? That we always idealize these systems as being, the one magma batch is coming up and nothing else is going to affect it, but very easily there could be several batches in there, especially considering there might be some breaks because of the 2018 collapse, right? So some magma pathways might have been compromised or not as easily used, or it's hard to really speak so abstractly, right? But you could imagine that you could have some separation between magma bodies as a result of collapsing of the caldera and splitting some of those pathways, right? And so magma could still be coming into the whole volcanic system, into the whole summit area, but not really connecting to this upper area. That's a possibility. It could still be going into this upper east rift area and filling in there and not making it into that shallow chamber as easily. That's a possibility. But what does not seem to be happening is it does not seem to be making it around the bend in the east rift zone and getting over to Pu'u'u area. So we're still seeing contraction over in the east rift zone, essentially from the stations in the east rift zone, Mana'u and eastward. It appears that they may have resumed their sagging. May be the best way to put it, right? Prior to the bulge, they were essentially refilling And there was suggestion of that happening here as a stabilization for mid-February to mid-April or so. But now that trend is apparently continuing the sagging there. So not getting as far as the East Rift Zone, but there's still a lot of area, and that's typically how it goes at the upper East Rift Zone. North of Ma'uma'u, where there's a big bend, and that's hard for the magma to get around and make that turn, so you kind of pinch off, and you have to be really pressurized and push the south flank a certain way, and that's a complicated part there, right? And likely as the rift zone is sagging, the south flank is adjusting as well, so it's a whole complex dynamic in there that's hard to really untangle, right? But suffice it to say that there is still some question, and it'd be interesting to really map out where the magma is able to get at this point. And for sure, you'd imagine it's coming into that deep chamber, and we're seeing reports from the USGS that it's still refilling the rift zone. And in the past, they've mentioned the rift zone up rift of Pu'o'o, but from the signals that we're seeing on our end, it may be even less than that. It might be up rift of Mana'ulu, in fact. Always have to wait for more clarity from the USGS on that. We're going to give you guys a preliminary look here at what some of this data appears to be here. So that's the GPS. That's the little wrinkle in the whole eruption forecast. And so after going through some monitoring signals here, I'm going to show you guys some of these other pictures that have been released by the USGS. So this is a May 7th daytime view. You can see more easily here the west vent on the left. And in the daytime, not a whole lot of red lava. If I zoom into it, you'll see it here. But I want to point out first the sunken southwest bay, and a sunken northeast bay here, and the more shiny flat part in the middle. We'll zoom into right there. Here is where it's red, is right in this area right in here. And that's that one southern overflow right through here. You can notice that there's a little area that's still liquid surface that's still foundering and not as active as this upper area, but exists over here below, right? And at the edge over here on the left, that's the remains of that tipped block that once formed that love island near the entry point of the vent. For those of you guys that have been following us since 3 months ago, of Valentine's Day, 3 months ago.
We have a $20 super chat from David. No message. Thank you, David. Mahalo.
Mahalo. So I'm going to scroll over here to the right, and you can see that there's also, I'm going to zoom in even more, the southern entry point here. You can really see this process forming a crust on the top, and the crust is actually being pinned against the levee, and it's buckling right in there. You can see these different pieces of crust are buckling right through here, and the lava is still coming out underneath that, as you can see down in here. All right, and so whenever that mini dam kind of breaks, or this crust lets loose, that you see that rapids coming through here, right? And from that upper pond to the lower pond, and that's the difference, the distance and the elevation right in there, right? And you can kind of see it's starting to crack in the middle. There's a little lava sausage roll coming up through this crack right through here, and all this crust is going to get overturned. You can imagine that's a lot of the stuff that's piling up on the edges and helping to form this levee. And here really you can see this levee pretty well. There it is on the edge right through here, and not as easy to see right through here, but you can see the lava surface is elevated and goes downhill and ends up at a lower spot right through here, right? And pretty, interesting. It's almost like a big, slow toothpaste ooze, and it's starting to look almost like when you see those spines and lava domes and silicic volcanoes come out. It's like a really, a more viscous, like a squeezing out clay from a package or something like that, right? It's like really semi-solid almost. So it's looking much less fluid over here, coming out like a paste and not forming any ropey features whatsoever, right? It's none of the crust. It's just kind of freezing pretty slowly. You do see these longer flow marks, these longitudinal striations, right, on the direction of the flow right through there. So this was taken on May 7th, and there's a couple photographs that show what happens next. And first one will go back in time to May 5th, and so we're now switching angles. We're now above the west vent, looking back from a different direction. But you can see here that the crust breaks apart, replaced with red lava, and the crust either sinks into the pit or gets pushed and rafts down these channels to the sides. So you can see we're looking, it's the opposite point of view, but our southern overflow channel is right here, our eastern one is over here, I'm sorry, the eastern one is here, and the southern one is right here. But we also have this more southwest area right through here that's overflowing back on May 5th. And this has now been all dammed up, possibly from pieces of crust, much like this one right through here. So we'll skip ahead to May 10th, and a similar view as well. Let me come in here to the original and zoom in so you guys can see similar process, right? A little bit better dam over here on this southern side, so no overflow going off in this direction. But you do see that foundering taking place here. And let me zoom it back out here and come back to just make sure we credit USGS for this, and show you guys that they are adding some interesting captions here. They do say that this event only lasted a few minutes and it was approximately 100 feet, 30 meters across. So foundering is less frequent than in previous weeks, they're saying as well. It's still persistent. And so you can imagine that's everything is slowing down, but foundering is still happening. When I show you guys those fast time lapses, everything is so sped up, it looks like it's just happening nonstop all the time. But really, these few minutes events is happening all in between one snap of that time lapse and another snap of that time lapse. So, which is about 20 minutes in a lot of the ones that we show you guys at the most. So something that lasts only a few minutes is something that you really need USGS on site to document, since we don't have that resolution minute by minute with the cameras. All right, so keep going on and we'll show you guys that there is actually a new webcam. The B1 camera has been inaugurated by the USGS-HVO. This is looking from the east back across to the lava lake. So it's getting to be sunset time. So the sun's right there in the top of the image. Not the best time of day to look at this. But the west vent is in a far distance over here behind the big island that you can see here in the foreground. And you really see the larger extent of the eastern portion of that larger crusted lava lake, right? We estimate by now that the lava lake surface is something like 98% or 99% crusted over of that entire eruption area. So if anything happens over here, this would be a great camera to look at. But right now, this is not the one to look at for lava. But you can definitely see some other features. And if something were to happen, with a lot of questions coming up, well, what happens if the thing does crust over all the way? Will lava keep coming out? And we don't know. We'll have to wait and see. But if it does keep coming out beneath that crusted surface, it could start popping up elsewhere through the cracks or along the margins or elsewhere. And in that case, this camera might be very useful. Interesting to keep an eye on that. The other option, of course, is maybe it's too much pressure and the flow will just stop, and we're seeing it stop independently of any crusting over just from the gas emissions from the source going flat, right? So interesting. I'm sure we'll debate this for this question over time, over and over again. But important to note that before the thing is all the way crusted over, and in fact the reason it may be crusting over is because the gas is leading it. The gas emissions are dropping first. And then the crusting happens, and then the vent is becoming more submerged. And so kind of the domino effect may come ultimately to the fact that the magma is going flat. That's feeding this little pocket of eruption here. Right, a pocket that's erupted 40 million cubic meters, right, 11 billion gallons. It's, for the volcano, kind of small if you consider 2018, for example, right, where we had 1.4 billion cubic meters. So that's the range there, whole different order of magnitude there. So relatively small in comparison. So that's the view from the east. View from the west is a KW camera. That's still up and half covered in shadow at sunset here, but the west vent's at the bottom. You see more of that downdrop block, and if you're to the east, there it is. And we scroll down to the last 24-hour time lapse, which is not yet available for the B1, but you can see it here for the KW camera. And it's smaller lava surface area right here in the foreground right below. So really you can see how it's only a few percent of that entire bowl crater area that's still active right now. All right, I'll keep coming through the webcams. Here's an F1 camera, most recent capture. So you can see just one frame still, right? Not a lot of open red lava on there, right? You see it's really almost all the way crusted over right at any instant in time. But if we scroll down to the last 4-hour time-lapse animation, you can see that they're still overturning, and so there are a lot of times where you do see not a whole lot of red on the surface, and then it flashes a brighter orange as the crust overturns, and that's that foundering process we're seeing there. And interesting to note, those spillover posts as it spills over out of the bottom pond and the upper pond simultaneously, right through here. It seems like this bottom pond over here may be becoming separated, but there might be a pathway right through here between this lower southern section and a lower eastern section. I've been counting them essentially as one unit here, although one could technically argue we really have 3 different ponds here, and these two may be close to the same elevation, or if anything, this one down here at the bottom, closest to the island, is the lowest one, right? So possibly 1, 2, 3 little cascading ponds here. The flow definitely goes that direction. If it goes from here into here, it's going to flow into here and then going out. So lava moving through 3 different ponds as these cool spots have caused divisions and separated that once coherent lava lake into 3 little pockets, 3 little puddles, as Jagger would have described them back 100 years ago. Okay. And we still have our S1 camera from the south, and there is a view of what that looks like. You know, that smaller area right through there. Show you guys there. You really can see the darker color of that raised lower pond that's right through here. Right, the lower pond now has margins against its northeast and its southwest. So the active area of that lower pond is only right through here. And the upper pond right in there. Fascinating stuff. That's S1 camera. Also no functioning 24-hour animation. So move on from that and finish off by showing you guys the earthquakes here. Earthquakes, really, if I look at show you guys a key here for what's orange. Orange is the last day, and my particular settings here, I'm showing nothing in the last day on all of Kilauea, in fact, right? Within the last week, yeah, some by the summit, some under the south flank, and some at the boundary interface with Mauna Loa over here at the Kauiki area, Kauiki to the north and west. So some other views of that. Here is the past week, the automatic map that USGS puts out, and a little bit more generous with the magnitudes that are being included. You can see more activity under the summit, and now we're coloring by depth. So the oranges and yellows are essentially that south flank depth, the reds being the shallower stuff. And really, it's all south flank, little minor adjustments right through there, and a little bit, you sort of see a little bit of a hint of something happening in the upper east rift zone, but not enough to really be convincing one way or another, right? But interesting how that pattern is right around the caldera there and upper east rift zone section, and you are getting a little bit in the seismic southwest rift over here as well, but very, very, very low levels. We'll look at how this develops over time as we look at changes in the lava lake and the supply level and all of that, and this is just, you know, something to note for the future as a snapshot of what might be to come, what changes we might see seismically. They're not happening yet. Looking at the past month rates, pretty steady, a couple little spikes up and down. That's normal. When you start looking at earthquake plots over time, that's just normal to have variations past month. And so we look at the past year, and slight rise here at the end of April, but really all still within this new eruption normal, and we have not returned to background levels prior to the eruption or even in the lead up more elevated areas as we were preparing to erupt right through here, intruding and then preparing to erupt in December. All right, and so once again, let's make sure everyone realizes that this is all information courtesy of the USGS-HVO. This is where all information is coming from. It's just a daily update right here. So SO2 emissions at 150 per day, measured on May 10th, that's where that comes from. Lava lake measurement, 229 meters, 751 feet, that's where that's coming from. We're not seeing updated East Rift Zone observations or anything different there. They're still unchanged in the report. And as far as the lake, they're noting circulation and intermittent foundering of crust in the smaller western portion of the lava lake. And lava has not oozed out along the perimeter of the lake over the past week. In fact, it's been closer to a month, right? It may be just under a month, the last ooze out that I saw looking at our long-term time lapses here. So still, this note here of SO2 measurements suggesting the eruption rates decreasing, and this could lead to a pause or stopping eruption here. So we'll wait and see what that brings in the future here. So that's where it's all coming from. Mahalo USGS. We're just trying to present it to you guys all coherently here. For those of you guys that don't have time to go and look at all different pages, showing you guys I don't know how many different pages and graphs here today. It'd be easier to look at one video than find all those 20 different graphs. And of course, we're brought to you guys by Hawaii Tracker, hawaiitracker.com. You can see all of our in-between updates, smaller bite-sized chunks and different coverage on that website there. And that's just the first of several mahalos that we're gonna give today. And I'll turn to Dane to help me out with that.
All right. Well, thanks for that presentation. We are brought to you by Hawaii Tracker, hawaiitracker.com. It's the best way to support us, become a member there. It's where we post all of our updates and information, text form, video form. That's the spot to go to grab it all. We are also sponsored today by Kalani Tours. Kalani Tours is a sustainability, but also a very interactive tour agency that does waterfall and volcano tours, as well as some coffee tours on Big Island of Hawaii. And they kind of go everywhere and try and give a little bit different tour than many of the big agencies that kind of just grab you on a bus and, drag you around. This is more of that personalized experience that many people are after. So if you're looking for something like that and you're on the Big Island, we're coming to it, check them out. Second one is Kilauea's Bar and Grill in the heart of Pahoa. This is some classic cuisine with a local twist. Really good stuff there. Their prime rib is great. Fish and chips is awesome. Indoor, outdoor dining, all that jazz. Full bar. Really good place to go for casual evening or grab takeout as well. So we thank our sponsors, and we're gonna get into a few questions, huh?
Yeah, let's discuss what the viewers want to talk about, even if we don't know the answers to many things.
Right. And so Sass Cactus says on YouTube, is Kilauea expected to get as large and high as Mauna Loa and Mauna Kea, or is there something particular about them? Also, is there an estimate for how long that might take?
Yeah, that's a great question. I think first order you would say, yeah, why not? Why couldn't it get that high? Especially when the two most recent iterations of volcanoes built out of this hotspot have been that big, Mauna Loa and Mauna Kea. Right? So why not? Why not Kilauea? The counterpoint would be, well, Hualai didn't get to be as big as that, and perhaps some of the other volcanoes didn't either as well. And well, there's complexity. We can start getting into it, and we really don't know in the end. We talked about a little bit about the hotspot dynamics, Kea and Loa trends, possible interactions, and changing of the hotspot and all that. So there are reasons for other variations apart from that. In the end, we really don't know. Given that the two most recent are big ones, then why not? Why not? As far as how long, that's hard to really know. It's thought that Mauna Loa might be in the order of 1 million years old. So, Kilauea, depending on how you measure it, might be 20, 40, 50% of the way there, as far as age, but it'll have to put out a lot more volume really to reach that height, right? As far as volume, Mauna Loa just dwarfs Kilauea right now. So we're tempted to go with the 1 million as a order of magnitude, more or less, plus or minus a few 100,000 years. As a rough timeline, that's already incomprehensible to humans. How long that will take, we're not going to see a whole lot of change. We see it. Oh, it's 1 foot taller, 100 years from the time when I was born.
Right.
Kind of thing.
All right. So Marin Purvis, one of our mods on Hawaii Tracker, asks about the new camera. She noticed that after it goes dark, there's a bright spot on the east wall, and it's still there in the morning, just before light, and was wondering kind of what your thoughts were on that.
On the east wall inside of the crater?
Yeah.
Is what you're saying? Yeah, it's interesting.
Oh, go ahead.
No. Finish it.
Richard made a comment that he thought it was a bright spot from gas emissions, a fumarole of some kind. And that, reminds me of some of the night vision or the night view from Fissure 8 after the eruption. We were looking at these little bright spots on the wall. I don't know if you remember that.
Yeah, absolutely. Yeah, we had to do this whole pixel analysis. We had to see is
Right.
that little spot of glow and the exact pixel F spot as previous, and I forget how many different
Right.
spots we found, right? But lots of different spots. The point being, there were lots of cracks that were glowing from remnant heat, even from the gas heat. In fact, I like to bring up that before 2008's opening of the Summit Lava Lake, the crack on the crater wall started to glow. That was the first sign that there was hot gas, right? And so we learned at that point in time that it doesn't take lava temperatures to cause the rock to glow incandescent. You can have just hot gas temperatures doing that. So that's really interesting to note that. We'll have to keep an eye on that and maybe bring you some info on that next week. But yeah, it seems quite possible it's hot gas coming out of that spot right there, and interesting because that does obviously lead to the conclusion that there is an easier pathway for the gas to come out there than other places that are not glowing, right? So if it's a weak spot already and the eruption needs somewhere better to come out, then that could be a candidate in the future. But that all said, the gas values are really, unless that's tapping a different pocket of gas or different pathway of the magma, then it's hard to imagine that's going to happen unless we see some changes in the gas, right? There's a lot we don't know about the gas. We've talked about multiple magmas, but we haven't heard any update from the very beginning as far as presumably the lava chemistry stayed the same, but we haven't heard of any change in that. Presumably the SO2 to CO2 ratio stayed the same, but I'd be curious to see if that's going to change here at the end, because as we noted in some of our Mauna Loa updates, there's reports of lava coming from below from great depth and then pushing the stuff above it up and out without mixing, and then that stuff is what causes eruption and then gets replaced by the stuff from below, and then you see a spike of CO2 at the end of the eruption that tails off quickly afterwards. So I'm curious if we'll see anything like that with Kilauea, which might indicate a different magma fresher batch from below. There's still a lot of question marks on how that goes, and maybe that crack becomes active in the future. Yeah, well, that's great observation, guys. Thanks for sharing that, and we'll keep an eye on that in the future.
The gas levels are just so incredible. 150 tons a day. I remember when we were talking, it was Water Lake, and it was at 70 tons a day, and we were talking about SO2 getting scrubbed by the water. There ain't no water scrubbing it now, and it's still it's incredibly low right now. We have a $25 super chat from good friend Gary Bryan. He says, appreciate your descriptive content regarding subtle observations. It's fascinating the complexity of inputs affecting change. Thanks, guys. Mahalo, Gary. Appreciate it. So a lot of these questions are more, meta questions. About Clarissa from Facebook asks about the process that might be involved to fill the caldera, become a dome again. Like, what is that? What is the time span of that type of process? Is that something that could happen in a human life, or in 1,000 years, or 10,000? Like, what kind of time span?
It really depends on how how big a dome you want there to be in there, right? If you're talking about a small dome within the caldera, that happened 100 years ago, and last time 1920, before the 24 explosion, there was a lava shield over current Halema'uma'u that was taller than the southwest caldera wall, right? So it wasn't going to fill the whole caldera just like that, and that that followed caldera collapses at least in 1868. There might have been some in the early 1890s, in 1832 and 1790. So there was a lot of space to fill, and so you imagine that within a human lifetime, it is possible to refill that whole pit with lava and form a lava shield within the caldera. Now, if you're talking about filling all the way up to the caldera walls, and that's a whole different thing. That is beyond a lifetime, more than likely. And that's with the caveat, of course, of it's all about the magma supply, because we're assuming that what's coming out throughout the record of human study here is what we see in the future. And so if you, for some reason, ramp up the amount of lava coming out, you can build it much more quickly, right? And so that's something that may be coming to get to a Mauna Loa size. You may have to do something like that at some point, actually, have more of a hotspot feed, where you have a lot of activity over a shorter time that builds up the surface of the volcano higher and higher.
Right. Well, we don't have that many more questions coming in. My question is to you: when are we going to start a little betting pool on when this thing ends? Because it feels like it's about that time. Like everybody pick a little day on the calendar and do something at Kilauea's for the winter. I don't know, but it feels like it's getting to that point.
Yeah, it's interesting. Yeah, and how are you going to define it being over, right? Because imagine if the thing does crust all the way over and we can't see it coming in. Is it still coming in? I don't know. What
give it a week to see.
What if here's an interesting wrench to throw in all of gears. Like, what if the input of lava into the lake is more submerged now, so the gas is bubbling into the lake rather than out of it, and so there's no open area to vent the gas, and the gas is all going into the lake rather than coming out. Right? If something like that's happening, then we might just see it kind of rising up. We haven't seen ooze-ups on the perimeter. That's what makes me think that's not happening right now. But would that happen again? Would we have ooze-ups if we crusted over the top? And would that be the only giveaway for it keeping going?
So is there like a pocket of gas you're envisioning down there, or is it getting like absorbed back into the lava?
Yeah, I imagine there's some kind of stratification, right, where you have some separation of the bigger gas bubbles, right? The bigger the gas bubble, the more buoyancy you can have, and the more it can actually rise and move to that upper layer. And the smaller the bubble, the more likely it just kind of goes with the flow and gets mixed in everything else, right? So you imagine there's a lot of small bubbles still all throughout the whole lava lake depth, but all the bigger stuff is going to work its way up to the top, especially if it's getting agitated by stuff coming into it. So I imagine almost like a froth, like almost like a foam that's below that crust at the top of it. Some layer that's more gas rich under there. That allows the lava to dive underneath that big island, without ever spilling over. We've never seen like any standing wave or anything like that by that big island. Lava just goes under and it just finds space in there. And the thing about the gas is really compressible, right? So it can change volume, absorb shape. So if there's there's all this volume of liquid going in there, the gas is gets compressed a little bit. No problem. There's plenty of space for that to happen. And I'm curious in the future to see the research coming out on that, right? I think in 5 years it'll be fascinating to see someone's model of how that's actually possible to actually model the stratification, the gas, kind of how much foam would collect. And right now we're just, seeing things happen for the first time, right? This eruption that we're seeing, 2021, may be the first Hawaiian eruption that we see the entire thing on camera on time lapse from beginning to end. Right. It wasn't the case before in Pu'o'o. It wasn't the case in 2018. The collapse we did see, right, but that wasn't as much the eruption. That was still fascinating. But this might be the first time from start to end. So it's we get a lot of questions sometimes of why isn't the tech better, but that's just where we are. That's the cutting edge right now. Is this might be actually the first one we catch from beginning to end, right? And so then we can study it.
Bo has a good little question here. So could a decent sized earthquake burp the pond?
Yeah. Absolutely. Yeah, in 1975, there was a crusted lava pond, and there was a 7.7 earthquake, and one-day eruption resulted. Essentially, burp the pond, exactly as you say.
Yeah, burp the pond. We're using that term now.
That's the big question mark when what happens there, and we'll have to wait and see. And that's the interesting thing of how it develops now is, as a surface closes in over the next week, 2 weeks, we'll get to see like the final development, the final surface adjustments when everything is really dynamic, and then we'll have to have a whole new canvas, and we'll go from there. So interesting changes coming up.
Well, I believe that does it for our questions. We are going to be premiering the next episode of Drones On, covering May 7th and 8th of the 2018 eruption. And the openings of fissures 11, 12, 13, and 14. So if you want to check that out, it'll premiere immediately following this. And appreciate everybody that tuned in. Thanks for the update, Philip, and I'm out.
Yeah, thanks everyone for support. Thanks for your good questions and good discussion as always. Mahalo, everybody. He's Dan DuPont. Oh.
One donation came in. Mel S on hawaiitracker.com/support. If you do want to support there, we always appreciated that as well. So thanks, Mel S, and thanks to everybody again.
Yeah, mahalo, Mel. Yeah, so mahalo everyone once again. We'll be back on Friday, bringing you guys a little bit more of Mauna Loa, and we will move from there. Kilauea one more week from today. We'll catch back up, and everything is in slow motion now, so it really takes waiting a whole week to see what really changed, and it's hard to every couple of days. Oh, one more piece of rock moved over here. At this point, it's not as meaningful, but week to week, it's really pretty exciting to see how the changes come in right in each new episode of our season here, and we're not quite sure when the finale is going to be, but it may be coming up, or we might get it to be continued, and we'll just have to wait and see. All right, so there's our wrap up there. So mahalo everyone once again. So for Hawaii Tracker, he's Dane DuPont. I'm Philip Ong. Aloha everyone.